Software Engineering Radio, episode 113, Building Platforms with Jeff McAffer.
This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio brings you relevant and detailed discussions and interviews on software engineering topics every 10 days. Thanks to our audience and the partners listed on our website for support.
So welcome listeners to another episode on Software Engineering Radio. In this episode we are going to talk about building platforms. And we have invited a guest, Jeff McAffer, to this episode. So welcome Jeff to Software Engineering Radio. Would you like to introduce yourself to our listeners?
Sure. Well, as you say, my name is Jeff McAffer, and I'm one of the original folks on the Eclipse project. I've been around it since before it was Eclipse, and I focus mostly on runtime level things. The Equinox OSGI implementation. I'm the RCP Rich Client Platform lead, and I also lead the Equinox project and a few other projects. And I'm on a few PMCs in the Eclipse board of directors. So I kind of do a lot of things around Eclipse in a fairly varied way. And I recently started a company around Eclipse called Code9, and we do a number of things in kind of the areas that we're going to talk about today.
Okay, cool. So welcome again to Software Engineering Radio.
Thanks.
I think we can just start with the topic of this episode, building platforms. So maybe before we discuss how to build a platform, we can talk about what is a platform. Can you give us a short definition or an impression from your point of view? What is a platform?
Sure. We've been doing platforms for quite a while. Obviously Eclipse itself is sort of one large platform, and I don't think we've come up with a scientific definition of the term or anything like that, but it seems like it really comes down to it being all of the GORP, if you will, all the stuff in the middle that you need to have to solve your application or solve your problem, but you don't actually want to write yourself. So it's almost like middleware in the classic sense of the term. It's all the things that you want to build on top of the functionality and the components that you take and put together to build your application system.
So many people think they think about Eclipse as the Eclipse Java IDE and stuff like that. So can you give us a brief impression what the difference is between a platform and an application?
Yeah, it's interesting actually, because the application is what you typically see as the end user, and the application may or may not be implemented based on a platform. So the IDE, the Java IDE that you mentioned, is in fact based on a relatively generic IDE platform, and then with a bunch of Java stuff glued on top of it. And so the idea here is that the platform is relatively generic. It's a set of functionality that you can compose and use, but the application is a particular composition of that functionality, perhaps with some additional pieces that go together, as I say, to address a particular problem. In your example, the problem of how to develop Java code, so making a Java IDE. But other people will take that same that same platform, and compose other functionality with it to build a C IDE. Right? And then other people will take even below the IDE platform is a rich client platform, and people will take that and compose it with other functionality to make an application for banking or for controlling space missions or a wide variety of things.
I remember people talking about this kind of infrastructure components as frameworks, so white box frameworks and black box frameworks. I think they got very famous in the object-oriented space. So what do you think? Is there a distinction between a framework and a platform?
Yeah, I mean, I certainly hear people talking about and saying, "Well, is that a platform or a framework?" And in historically we haven't paid much attention to that sort of distinction. I think we have implicitly, but we don't sort of walk around talking about it explicitly. And the way I look at these things is relatively informally, and talk about platforms as being, like I said, collections of functionality that you can put together to solve a problem. And it's something you build on top of. If you look at the English meanings of the word platform versus framework, a platform is something that you sort of stand on and you build upon and you do things on top of. And a framework tends to be more inclusive or prescriptive in as much as it kind of surrounds you and it provides you an environment in which you work, not on top of which you work. And there's no good or bad here. There's no right or wrong. I think both are essential elements of a good software system. And in fact, many platforms and much of Eclipse is built as a composition of frameworks, if you will. You look at Equinox, the runtime that's underlying Eclipse. It itself, it's an implementation of the OSGI standard, and the OSGI community talks about that as a framework. They call it the framework. And also in Eclipse, you'll see, within the UI, lots of different frameworks for the whole perspective notion, perspectives with views, perspectives fit inside of a window. There's all these facilities that the UI provides you that you just sort of hook into and live inside of, and it provides all this management for you. It runs the event loop and that sort of thing. And that's much more of a sort of frameworky notion. But the composition of those frameworks together form a platform that you can use to solve your problem, because everybody needs a UI, everybody needs some componentization and some runtime elements, that sort of thing.
Do you think that in this setting, frameworks are becoming smaller?
Yeah, that's a good question. I think I think that because I view frameworks as being somewhat more prescriptive, they tend to be more focused on particular, for example, in a UI world, particular workflows. Here's a framework for doing dialogues or wizards, right? So it's that workflow. And whereas perhaps in the past, maybe the frameworks were a bit larger and had a broader scope. So I think maybe what we're seeing is a componentization of frameworks, if I can say that, right? So breaking them down into smaller frameworks. And that's good because it allows the frameworks to give it, again, going back to this notion of composition, it allows people to assemble frameworks in a way that better suits their requirements. So I might have 3 or 4 different dialogue frameworks or wizard frameworks, and depending on the workflow I'm trying to give my users, I might choose from those. But the overall collection of that set of frameworks I sort of view as a platform, because it's the stuff, it's all that stuff I can take and use in building my solution.
Do you think it's more moving away from these old, very huge application frameworks containing everything, more into platforms consisting out of a set of smaller frameworks that you can compose or maybe not compose if you don't like to?
Yeah, I think that's generally the trend that I see. People moving, like I say, to the finer grain pieces and composing the bits of functionality that suit their particular purpose. So if you think way back to the I can't remember the name right now, but the whole Mac application frameworks, those were very broad and provided a very rich environment, but it was a rich environment for that relatively constrained set of applications. That was great for Mac end users because they got common look and feel and consistency and everything, but that's not good as a widely used generic platform that people are going to apply in many different ways.
Do you think there exist different kind of platforms? You talk about the platform for very for more generic application building maybe. So are there different kind of platforms from your point of view?
So I think there are many different platforms, but I'm not sure that they're really different in terms of kind. It's more in terms of content. I think platform itself, the notion of platform has some particular characteristics about it, and we certainly within Eclipse see, the rich client platform, the IDE platform, and platforms built on top of that. People like, the famous example is the NASA guys and Maestro and Ensemble is their platforms for building particular kinds of space mission software applications. And they've gotten together, and whole groups of diverse people have come together to put various pieces of function into their platform, and then perhaps those same people or others take that platform and build applications for particular missions, in the same way that people come to the IDE platform at Eclipse and build Java tooling or C tooling or PHP tooling or whatever. So I don't see them as being, I think definitely they're domain-specific platforms, but I think that's just a difference in the content.
If we think about developing platforms, do you think what are the main differences between developing a platform and developing just general applications, or maybe applications on top of platforms?
Right. So there's a few things. It's kind of funny. The guys on the team, on the Equinox team, sort of tease me about this, but I have sort of three mantras or three things that I always juxtapose with each other. And one is producer versus consumer. I'll talk about these in a second, but I'll just enumerate them here. So one is producer versus consumer.
Mm-hmm.
Another is mechanism versus policy, and the final one is product versus plugin. And it really comes down to the mindset that you have while you're developing your code, whatever it is. So if you're developing for a platform versus developing for an application, you really do need to know which hats you have on and what things you're building. So just to loop back here, to that the producer versus consumer. Whenever you're writing a piece of function and making a decision about that piece of function, you do well to sort of think, well, what hat do I have on here? Am I taking the view of the consumer of this function, or am I just producing some function and I'm not really trying to constrain or make too many assumptions about how it's going to be consumed? So a classic example here is something like menu entry placement. So a guy in Eclipse writes an action. Actions are the things that show up in menu entries and on toolbars and control keys and that sort of thing.
Mm-hmm.
Commands, that kind of stuff. And when you write one and you implement the function that the implementation of the run method. So that's cool. You're implementing that. You're clearly a producer. You're writing something somebody's going to call run. If there's going to be an active selection or whatever, you're going to do some operation on that selection, and that's your action. That's good. Strictly a producer point of view. When it comes down to then contributing that in, say, a plugin XML, in Eclipse, you have the mechanism of declaratively expressing extensions to the UI, for example. So you can declaratively express that this action should have this label with this icon and should show up at a particular spot in the menu hierarchy. When you do that, you flipped over, and now you're a consumer, because you're placing that function in a particular spot that only is going to make sense in a particular class of applications or consumption scenarios. So it's very important to distinguish between those two, and when you mix them, you end up with functionality that can't be reused beyond the scope of the original viewpoint, because you had a consumer viewpoint when you actually place those things. So, going all the way back to the rich client platform and the evolution of it, a lot of what happened there was people looking at the IDE platform that was Eclipse, 2.0, 2.1, and saying, well, I don't want a file save menu because my banking application doesn't make sense to have file save. And so a lot of the work that was done in producing RCP was generic. It was taking the consumer hat off, because we had the consumer hat of being an IDE consumer of this infrastructure. We took that hat off and put on a producer hat and said, look, I'm going to provide a mechanism for placing menu entries. And you can place your menu entries wherever you want. And I'm going to give you some pre-canned menus or actions, for example, that you can use, so just to simplify your life. But you can place them wherever you want, and so you really separate between producer and consumer.
Mm-hmm.
For mechanism versus policy, this is really a friend of or related to producer versus consumer, because we talked about the action mechanism and the mechanism for plugging actions in and defining where they are and that sort of thing. But then you would apply on top of that as a consumer a policy that says oh well, I can place menu entries here, and I can give them these labels and that sort of stuff. So by for consumers, producers, when you're producing something, if you separate clearly between mechanism and policy, then your consumers have more power because they then have a richer policy set that they can use when they're defining, say, like my example of menu placement. Another example that came up fairly recently in our development of P2, the new provisioning work that's going on at Eclipse and Equinox. We had this mechanism, or we had this code. We had several copies of this code that was watching directories and looking at directories and watching for changes. You'd put some plugins in there, and we would discover them, and we would do things to them and stuff like that. And there were a number of scenarios, and we had essentially copies of this code that was doing the same thing. And when we sat back and looked at it, we really realized that there's one base mechanism, the directory watcher, and there were a set of policies that talked about where to watch, what directories to watch, when to watch. Do I watch just at startup? Do I watch after startup? Do I poll? How often do I poll? That sort of thing. And then what do I do when I see that there's something changed? Do I just generate metadata? Do I generate metadata and install? Do I ask the user? All those kinds of things. Those are policy statements. And what our challenge was as implementers or producers was to produce the mechanism that would enable those policies to be enacted. So that's a very powerful distinction. And the final of the three sets of things I talked about, product versus plugin, this is really putting on different hats of, am I writing sets of functions, so plugins that are sets of function, or am I writing a product? And when you are writing sets of function, you try to, again, separate between mechanism and policy and put on a producer hat. So you're not trying to place things in menu entries. You're not trying to define the exact semantics of, or behaviors of when you look and what you do and that sort of thing. That's the job of a product producer. So product producers have the ability to, and requirement of worrying about placement of things, workflows, organization of elements, branding, all of those kinds of things. It's the composition problem. Whereas as the product or plugin writer, they're more concerned with the policy mechanism, API, extensibility, all of those kinds of ideas. That was kind of a long-winded description of or comment on your earlier question about the difference between platforms and applications. But I think it is actually a very important important element to consider when you're writing software.
Sounds like you're thinking a lot about building APIs and thinking about how the API should look like for the application developer that is using the platform. So
Mm-hmm.
how important is the API design for building a platform?
I think it's critical. API design, sort of impacts everything from your ability to, how flexible something is, to your ability to evolve it and maintain backward compatibility. It really speaks to the quality, I guess, if you want to say it that way, of the platform. Whether or not a platform is good, triggers on a number of things, but many of them come around, the quality of the API, uh, how concise it is. Having big verbose APIs with multiple ways of doing things tends to be very confusing for consumers and tends to be very hard to maintain. So the elements of API. Well, we could go on for a long time about that. But yeah, API is critical to creating a good platform.
Yeah, maybe we can come back to the API
Sure.
questions later on, especially when we maybe talk about backward compatibility, which is very interesting, I think, for building platforms. Um, so, what do you think? What makes a platform a good platform?
Well, like I was saying, I think primarily it's quality APIs, ease of programming, so it has to be consumable, so easy to compose pieces. In the case of Eclipse, I think a lot about composition and how to put things together in reasonable ways, making that easy. And fundamentally, if you were to look at a platform and say, well, is this a good platform or is this a bad platform? I think in many ways the proof is in the pudding, and you say, oh, that's kind of an English idiom, but it's you look at how many people are using it to do lots of different things. If you can pick up, in our example of RCP in Eclipse, if you can pick up the rich client platform from Eclipse and say, well, is it a good platform? Well, who's using it and what are they doing with it? Well, that's a pretty broad spectrum, and a lot of people are, I think, getting a lot of value out of it. So, it's got its problems for sure. There's no doubt about that. But I think it really is a fairly good platform.
But what should I do if I build a platform to make it a good platform?
So I think there it's key. So I think it does come back down to API, but then you might look at, so what are the elements of designing a good API? And in that case, one of the key things is having lots of consumers early on. So we had lots of clients of your API earlier on, because they'll all come to your set of function, whatever it is, with a different viewpoint. They'll all want something different out of it. They'll all expect to use it a different way, expect different levels of flexibility and composability, extensibility, all those sorts of things.
Mm-hmm.
So by having lots of different people interacting on it, you get those viewpoints. And it's not to say that you're always going to satisfy all of them 100% of the time. You're going to hopefully hit a fairly high percentage of them. But having those viewpoints and understanding that, hey, somebody might want to use this thing for something other than an IDE, or something other than this particular use case that I had in mind. It makes it harder because you're then building a platform. You're then building generic function as opposed to more specific function, and you're having to separate mechanism from policy, which means you do have to be a little more rigorous, and you have to define more API or different API. But in the end, it becomes much more worthwhile, more useful in the end, I believe. So going back to your question of how to do a good platform, how to create a good platform, having lots of consumers, lots of interaction, and much of it comes back to communication and interaction.
Mm.
So you understand what your consumers are wanting, they're understanding what you're producing, and you get that feedback loop. And in the Eclipse project, in the Eclipse project particularly, we are able to do what we call, eating our own dog food, which is, we use the stuff we produce. And that has been, if you really reflect back on why that particular team has been successful, personally, I think it's largely due to our ability to eat our own dog food. And unfortunately, it's a sort of rarefied situation because not everybody is producing the tools that they use to produce the tools. You know what I mean? It's like, we're doing a Java development environment written in Java, so of course we can use what we produce to produce the next version of the environment. But if you're doing I don't know, business integration tools or web tools or a banking application or whatever, you don't really use those things in your day-to-day implementation of that application. So you need people who do use it and who do consume it and will give you that tight feedback so that they'll tell you. And it's not just good enough to have people tell you things. They have to have faith that there's value in them telling you these things. I recently went through essentially a beta program for some new application, and we were all asked to use this new application and give feedback. And we were given a Bugzilla or whatever, a bug reporting system to give feedback into, and that's great. I was all for it, right? I went and I got the stuff and I installed it, and within about the first 5 minutes, I had 10 bugs entered, or 10 issues that I'd come up with that would really, I thought, be useful and improve the stuff. So entering all these bugs and all that sort of stuff, and it was a complete black hole. Never a single word back on any of them. I never understood whether they accepted them, whether they rejected them, whether they were fixed them, anything. And so I was just like, well, okay, well, why am I bothering? Right?
Yeah.
And it's perhaps a bad attitude, but people have to value their time. So if you can instill upon your consumer community a real sense that what they think and what they say matters, then they'll give you that feedback. And that feedback is as critical. It gets your replacement for being able to eat your own dog food, essentially.
Mm.
And that's critical to making a good platform in my mind.
Yeah, I agree completely. Um, but it sounds not like a trivial task, right? So for a platform, you typically have multiple clients and maybe many clients, and you said it's good to have many clients asking for many different things, but then you need to decide what to implement and what to implement maybe not, right?
Yep.
So you need to somehow to set the focus for the platform development, or you make decisions, and maybe you make the decision that you will not going to implement a specific feature that a client of the platform ask for. So they maybe get disappointed. So what do you think? How should you deal with this specific multiple client situation?
Right. Yeah. So that's a really good, a good challenge. And what I personally think makes sense is it goes back to this whole communication issue. And if people are, and just going back to the specific thing about putting in bugs or whatever, setting in requirements is the same thing. If people giving you input and just seeing it essentially vaporize and nothing ever happening and they don't see why, then they get discouraged and they go away. If they see that there's a longer term view, so if you have a long term vision for what it is you're building and you can effectively communicate that to people, then they have a context. They understand where you're going and why you're behaving the way you're behaving and why you might not be implementing the things that they're asking for or doing it in the way that they ask for it. If you can situate it in terms of another group and say, well, okay, here's these, you two have very similar requirements. You're phrasing it this way, you're phrasing it this way. But what actually is happening is under the covers, it's the same mechanism, and you just are applying different policies to it. And so we're going to implement this mechanism, and you guys implement the policy, or some way of getting them more involved. I find can be useful,
Mm,
and it's also good, I think, for exercising the API or reducing your API footprint, because if you can make, like a lot of Eclipse, we have started out and we had something built in or something assumed. Let's just say CVS, right? Our CVS support, and it wasn't built in; like it was a separate plugin and everything. But pretty much all the infrastructure in the platform assumed that you were using CVS, and there was
mm,
lots of sort of certain tie-ins, and there weren't as many life cycle points as other repository providers might have needed. And so that's fine. That was our first off. And then other people came to the table and said, well, hey, but wait a second, we want to put in subversion, or we want to put in clear case, or we want to et cetera, et cetera. And on the surface you say, oh, crap, we're going to have to redo this whole big thing here and provide this extra sort of functionality over there. But if you step back and you look at, well, what is it they actually need? And it turns out in many cases they just need a set of hooks or an extensibility point or then a lifecycle event or something like that, where they can hook in their specific stuff. So that's again, this policy versus mechanism thing. We have a mechanism that's walking through this certain set of process of committing things to a repository or whatever. And then there are different policies that different repositories require. When you save something, the repository needs to be able to check and validate that the save is okay, that you are actually allowed to save it, for example. That's a problem you don't have in CVS, but one that you might have in ClearCase. Right? And so by
mm,
identifying that mechanism, the point at which they can do that, and providing a point at which they can hook in, then they can define their policy to hook in at that point and do whatever they need. So one way to spin this around is to essentially look at it as enabling your clients to do what they need by doing as little as possible in the actual platform. So
but
that's one way
mm,
to deal with it.
but at the end, you can come into the situation where you have to decide which feature to implement, and
Yeah.
maybe implement feature A and feature B not. So how do you decide? How do you prioritize between those features from multiple
Right.
clients?
Yeah, I think that comes back to the long-term vision. When you know what you're building, then you can see off down the road. I'm not talking like 5 years, just a couple years, whatever, right? Just something longer than the next release, so that you can understand if it makes sense, if the choices you're facing, which ones make sense in the broader context. of where you want the platform or whatever it is you're producing, where you want that to go. And so if you're faced with two teams that hold equal sway over you, whether it's monetary or influential or whatever, and they're both proposing sets of function or feature that is very important to them. Uh, Ideally you can find some commonality in there and you can enable both of them. But in cases of actual conflict and where you can really only do one or the other, uh, you know, there's so many elements that come into that decision. I don't think there is a sort of prescriptive answer. But having a long-term vision and knowing where you're going makes and communicating that to these people so they can understand and perhaps rephrase their requirements in the context of this longer term vision. I think that can help a lot.
But you still can end up with you have just limited time. Maybe the requirements are all good and all fitting into these long-term vision, but you still have limited time and you need to decide what to do for the next release or maybe for the um, release after
Sure.
the next release.
Sure, and by having that open discussion, then maybe it's the case that they can say, well, oh, you know what? I understand what you're saying, and I'm fine with getting this full set of function I've been requesting in 2 years instead of next year. But for next year, we really want to do this. So can we trim that down and can we do this smaller piece that's still on the roadmap? It's still in the right direction, but it's an incremental thing that they can do and they can use to get around their immediate problems.
Okay, so how important is backward compatibility from your point of view?
Well, it's if you want to retain your community, they get really upset generally if you start breaking them every release. We see that a lot in Eclipse, and we work really, really hard to not break people and to maintain binary backward compatibility. It's extremely difficult, and sometimes we fail, and we get told pretty quickly about those failures. And sometimes there's nothing. Sometimes it was a mistake, and sometimes there's just nothing else we could do. We had to fix some bugs, and that meant breaking something else in a controlled way. Um, but generally, backward compatibility is extremely important for platforms, and that's what makes them sort of pretty interesting and challenging to produce. Is you have to getting your API right up front. Of course, is nobody ever gets it right the first time. It takes you 3 times to get it at least to get it close to being right. But doing it in it comes back to the communication and stuff. The more you're communicating with your consumer base, the more different viewpoints you have on it, the better understanding you have of what it is you're producing, then you have at least a better chance of producing something that is sustainable.
You mentioned the term binary compatibility. Just as a
Right.
side note, can you give us a short explanation what you mean by binary compatibility in contrast to maybe source compatibility?
Sure. Yeah, so binary compatibility is essentially the ability to just take an already compiled, in the Eclipse context, take an already compiled bundle, and that might use some function from a lower down piece, and reuse it without having to recompile it. So the classes will load, all of the Java language requirements are met. So as an example of something that breaks binary compatibility is if I, as an API designer, produce an API, and we'll just call it foo, an interface, a Java interface called foo, and it has 2 methods on it. And if my API says or expects that you as a client will implement that API, so you'll make some class bar that implements foo, and as a result, you'll have to implement those 2 methods that are on foo. If I then turn around and add a method to foo, then your implementation of foo will be broken because I'll have 3 methods on the definition of foo, but you'll only have 2 methods on the implementation of it. And that class, your bar class, will no longer even load into the VM. The VM will fail with a verification error, or whatever kind of error at runtime. And so that's clearly breaking. Your plugin just will not work. It just doesn't run anymore, and that's bad, right? Because you've got all these plugins shipped out there and people using them, and they want to be able to move them from 3.3 to 3.4, et cetera, or whatever version to whatever version. Source compatibility, source compatibility is where there are certain kinds of changes you can do that aren't obviously changing, but because of the way the Java language or the Java compiler works, you may need to recompile something to cause it to work again. So one easy example of this one is if you have a constants in Java, typically you declare them as public static finals, something like that. Public static final string, and then you give it some value. And what happens at compile time is those static finals, those public static finals, actually get inlined. They don't become, the value gets inlined in the referring class. So they don't, it's not a reference to a field someplace. So if you change the value of that field, you actually now have, and I've already compiled my class, then I've got the old value, you've got the new value, and if, for example, there's an equality test someplace that's checking to see if these two things are equal, it's of course going to fail. If I just simply recompiled my code without doing any code changes, I just recompile it, then I'll be updated, because now I'll have a copy of the new constant value in my class file, and everything will work fine. So that's one of those things where, if you can expect people to just recompile without doing any code changes, then you can do certain changes that otherwise you wouldn't be able to, because they would break binary compatibility.
Do you have some ideas how to maintain backward compatibility, maybe binary backward compatibility? So what are the key maybe patterns or issues you should take care of if you would like to stay binary compatibility with your platform development?
Right. Well, again, it all comes down to API and having good API. And there's a saying, it's like good fences make good neighbors, right? Is if you have clear API and the API is functional enough that people don't need to reach in and use internal stuff, then as long as you can maintain that API, then your consumers are happy because they're basically unaffected by implementation changes. So there's a whole raft of elements that go into designing good API and extensible, evolvable API. In fact, there's a really good document that's evolved over the years on the Eclipse wiki. I think there's a wiki area called API Central, or I think it's API Central, on the Eclipse wiki, wiki.eclipse.org, and just go there and search for API Central, I think it's called.
We can put a link in the show notes.
Okay, great. So I'll make sure I'll give you the good link. But yeah, there's a whole bunch of information on the Eclipse wiki that really helps you. It really talks about the API evolution issues, and what is a problematic thing, like defining like failing to tell people whether or not a particular interface should be implemented by the consumers, or whether it's expected that it's just going to be implemented by the framework or the platform itself. Being very clear about your API. There's a whole bunch of challenges that come into play with Java 5 and generics. There's a whole number of gotchas, things that you wouldn't quite expect. By specifying generics a certain way, you can inhibit your ability to evolve those APIs. And the documents on the wiki have sort of concrete examples. It's much easier to see in code, so I don't really want to go through trying to describe them. I'm waving my hands frantically here, but you of course can't see that, so it's not going to help at all. So back to your original question about making API, sort of evolvable APIs. So I think the number of pitfalls and issues that are enumerated on the wiki, those ones are good, and a lot of what we talk about too comes back to communication and making sure you have lots of interaction on it, and completeness of the contract. API is essentially a contract, and the completeness of that contract definition is very important. And one of the other things that we see that comes to play here is, not all API is sort of, or, crystal clear, in the sense that it's not crisp as to who ought to be using this. And in many cases, once we've introduced componentization here, we have relationships between components, for example, that aren't API relationships, but they're more like a friendship style relationship. So we have this notion in Eclipse of it's called xFriends. And so when I have a package that encapsulates my API, and I want to export that package, if I just want to allow you to use it because you and I are a collection of, form a tight collaboration to produce some sort of function, I can say, okay, well, I can export my package and then just mark it as xFriends Martin, and that means that only you'll be able to see it. In OSGI, you actually get strong fencing off of APIs. So if you don't export something at all in your bundle manifest, then it's just plain old not visible to the outside world. There's nothing they can do that will allow them to load that to refer to those classes from code. And so, if you have really a couple of different, you can export something, in which case everybody can access it. You can not export something, in which case nobody can access it. But there's this middle ground that we need to walk, where I want some friends to be able to access it. And so I can export things, mark them as, mark it up with who my friends are, and then those people will be able to access it. And we have an additional mechanism called xinternal, which allows us to export everything, mark it as internal. So essentially we're telling people that they ought not use it. But in some cases, we've got researchers and innovators who are looking at Eclipse and saying, well, I really want to push it that next step. And I really want to go and to do that advanced stuff, they need to be able to reach in and twiddle around with some internals. And they'll feed it back into the community and say, well, hey, look, here's what I had to do. We need some new API here or whatever. And so for the next release or some subsequent release, it'll all be fine. And then there are other people who just like, I'm shipping a product. I need to get this job done. I don't have time to wait for an API evolution, which might take a year or something. I'm working around a bug. I'm doing whatever. I'm going to reference this internal, and I take full responsibility for the fact that I might be broken in the next release because I've referenced some internal thing. So our tooling supports all of that and tells you when you're doing something you ought not be doing. And so I think that's a critical part of it as well, is having that sort of complete definition of the API signature for a bundle as a whole, as a component.
And getting the feedback from the IDE that I noticed that, oh no, now I'm using some internal stuff instead of official API, right?
Right.
Because otherwise the automatic import features from the IDEs, they're so nice that I do not even recognize in which package class that I'm using is in, if there's an internal in the name or not. I don't know.
Yeah. So we've tended to put internal in the package names just as it used to be the rule, and now we've got xinternal and xFriends, and that's really what defines API-ness. If something is exported and it's not marked as xFriends or xinternal, then it's likely part of the API. But actually, I want to touch on something, if you just quickly here, because you started
Sure.
talking about packages, and this is something, when we talk about API evolvability and that sort of thing, one thing we've discovered quite interestingly over the past few years is that packaging, like the use of Java packages, is actually quite important. When I started out doing Java code, I really didn't pay much attention to it, and I thought, it's whatever, it's kind of like how I want to group it so that the classes are together, and when I look at them in the IDE, that kind of thing, driven by just development tool issues essentially. And what happened is when we were going through the RCP effort, this is 3-4 years ago, we had cause to refactor a bunch of plugins. So the runtime, we had a plugin called Org Eclipse Core Runtime, and we had another plugin called Org Eclipse UI. And those, as the names sort of imply, were the runtime and the UI, basic pieces for Eclipse. And we needed to refactor those in the course of doing our RCP efforts. What happened was inside of each of those bundles, we had packages that had multiple concerns mixed into them. So in the runtime package, we had the plugin model, we had the extension registry, we had a bunch of infrastructure pieces, just helper classes and exceptions and stuff like that, and a number of other pieces all mixed into the package that's called Org Eclipse Core Runtime. And so when we went to refactor our bundle and split those all apart, we ended up with that package being split across multiple bundles. And while technologically that's okay in OSGI can handle that to a certain degree, it's got a number of problems. First of all, there are some runtime issues in terms of dependencies and how you can specify things. Because OSGI's unit of delivery is bundles, but its unit of dependency, its finest grain of dependency, is packages. So I can specify a dependency on a particular package, but if there are 3 copies of that package laying around in the system, OSGI doesn't have any really decent way of figuring that out, right? I mean, there are some things you can do, but it starts to get really messy, and it's also from a sort of design point of view, if you think of packages as having there's some reason why you gave it a name, and that name, likely has some meaning. So if that's true, then why do you have that same meaning, that same name split over multiple bundles? Presumably those are different things. So the lesson to take out of this is that you should really think about your package naming carefully and what you put into what package, and think of it in terms of separation of concerns. And we should have separated out our utility classes from our real functional classes, and we should have separated out the extension registry classes or types from the plugin definition types. And there's good reasons why we didn't in some cases, and in other cases it was laziness. But now I find I have a lot more packages because I'm much more aware of this. Oh, well, that package actually is something completely different, and I might want to be able to move that into a separate bundle, as an example. So that's something that helps you evolve your API, so that once you've done a change, you can end up with names that make sense. Because now we have a bunch of package names that don't make sense anymore because the context has changed. So that's just one of those things, because you can't change a package name without breaking API, right?
But it seems to me that there are relatively few changes that I can do to the API without breaking the client, right?
Right. So there's things you can do to mitigate some of that. So for example, if you have an interface, back to our example before, where you have an interface that you're expecting somebody to implement, by providing an abstract superclass that they can use, then if you add, my example was I added another method to the interface. Well, then I can add if my expectation is that all clients will extend some abstract class that I give them, then I can add that method with a default implementation to the abstract class, and I won't have broken anybody. So I'd point people back at the wiki page, and it talks about a lot of these issues, and there's also some good tutorials they do every year. Pretty much, there's an API tutorial at EclipseCon, and it's generally very well received, and it's very well done. So that material is also available.
So I assume that there as well mentioned these techniques like compatibility layers and versioned interfaces and stuff like that.
Yeah.
Okay.
Yeah.
That's cool.
So I did want to mention one thing, because it's a bit of a plug for a tool that's just coming into Eclipse, and so we've recognized really this importance of API, and in Eclipse 3.4, the release that's coming up in June, there's some API tooling, and what this really is it does a number of different things. One is that it helps you understand when you've broken API. So given some baseline, so for example, if you take Eclipse 3.3, and we're currently developing Eclipse 3.4, and you say, well, okay, 3.4 should not break any API that's in 3.3. So it takes 3.3 as my baseline, and then it analyzes your current code, the 3.4 code, against the 3.3 code, compares all the signatures and all of the other things that go into binary compatibility, and tells you, as you're developing the code, whether or not you've broken compatibility. So in my example earlier with the interface that I added a method to, as soon as I saved that interface, the API tooling would come back and say, hey, wait, you can't do that. You just broke compatibility, right? And I said, oh, yeah, darn, you're right. So that's one aspect of it. Another aspect is finding all references to some of your code. Now, of course, there's Java search and that sort of thing, but it requires you to have all of the code. You might not always have all of the code for all your consumers. So, for example, if you're working in a large organization that has many products based on Eclipse, you're not likely to have all of those things installed on your machine or available to your IDE while you're developing code. But you can, with the API tooling, essentially get an API reference signature or footprint from all of those products. That's much, much smaller than the original code. And you can have that available. And then you can do searches for references. And what you end up getting told is, oh, yes, there's a bundle over here, and it references that method or that field or that type. And so that's really handy for the cases where you're either trying to find out how broadly used is an API. So you say, oh, well, look, man, 1,000 people use this. Okay, it's really important. I can't, don't want to. I want to find out more about how they're using it or something. Or there's some API you think that nobody ought to be using, and so you say, well, why is somebody using that? And then you go off to that team and find out what they're doing. Or those places where you've got internal code that you want to change, but you want to be aware that there might be somebody, you're trying to be friendly and realize that some people are using internal stuff. And so you go and you can do a check and say, well, who's using this internal method or this internal type? And you can discover those references. And then there's a third element to the API tooling that is version number evolution. And so in Eclipse, we have version numbers on our packages and version numbers on our bundles. And those version numbers have semantics. It's sort of like it reflects the rate of change or the kind of change in a bundle and or a package. And so what the API tooling will do is say, well, you know what, you just changed this bundle in this way, which means you should have evolved your version number. You should have changed like the second segment in the version number or something like that. And so it'll tell you that and help you maintain those signatures. And then other people can specify their dependencies appropriately.
Oh, cool.
Yeah.
That sounds cool. But it sounds like we could record a whole episode on this API design and backward compatibility topic, right?
Yeah, I think so, yes.
I think we should close this episode, and maybe you would like to give some kind of pearls of wisdom to our listeners, some closing notes.
Well, and I hope that I've given a few pearls of wisdom already, but I guess the thing I'd say about platforms in general is, in essence, Equinox and the base pieces of Eclipse are a platform for building platforms. Or maybe even you look at it as a framework for building platforms. I'm not sure, but it really is this. Platforms are. I'm seeing it more and more, and to a certain degree, it's maybe I'm just attuned to them now, but I see the platforms coming up in all sorts of different industries. Platforms have the ability to be transformational both within a business but also within a whole industry. I mean, the Eclipse IDE itself pretty much changed the landscape of software tooling, at least, for a large chunk of it. I mean, they used to have a lot of different tools, and now we've really got Eclipse, Microsoft, and Sun. And we really kind of changed that whole landscape by building a platform that other people could use. And I think RCP also has a similar effect. And then in particular domains, we see talked about it in the NASA context with the space mission software, and it really is changing the way that they're developing their software to great effect. And I see that in other industries, people that I've been working with recently, doing things in their industry where, the healthcare guys is an example. Healthcare software is very fragmented and very proprietary and locked in stuff, and now people are starting to see the value in a platform. Let's get together all the stuff. We're all doing the same common commodity pieces. Let's just get together, build a platform, and then we can step up a level and build the things that we're good at, build the things that we have domain knowledge or that are domain specific, and raise the level both of our code, what we're doing, and also the level of what our users see, because now they don't have to, now they have world-class UIs because they don't have UIs that were built by a bunch of people who, don't really know how to build UIs, and that's because it's hard, right?
But you mentioned the healthcare guys, and this brings me to the idea of how does this platform building relates to product line engineering? So we had several episodes on product line engineering, and the people there mentioned that okay, building platforms, that's the old way. Doing product line engineering techniques is the better idea. So what is your opinion? What do you think? Do you have an opinion on that?
Well, I'm not so familiar, I guess, with the details of what it means to do product line engineering, but at least superficially, it seems like they're very much related. I think that platforms that are tailored to specific domains or specific types of applications, may well just be another way of talking about product line engineering elements. I'm not sure.
Okay. Any other pearls of wisdom for the end?
Yeah, I think, API and communication, just to recap, you get better API by communicating more and interacting more with your consumers, listening to them, and, don't be afraid to say no, right? It's you've got to say no to maintain the integrity of your API, and you've got to say no so you keep the communication channels open. Just leaving it go silent leaves people in limbo, and they don't know whether they need to find another option or whether their problem is going to be solved for them. So communication is key, and highly release early, release often, get that interaction and the feedback, and shoot for people to help you eat your dog food, right? And you have to get in their boat to pretend that you're eating your own dog food, essentially.
Great. Thank you very, very much for being on the show, Jeff.
Okay, well, thank you. It's been a lot of fun.
Thanks for downloading and listening to Software Engineering Radio. Software Engineering Radio is an educational program brought to you by Hillside Europe. If you want more information about the podcast and all the other episodes, visit our website at se-radio.net. If you want to support us, you can donate to the SE Radio team via the website, or you can advertise for SE Radio, for example by clicking on the Dig, Reddit, Delicious and Slashdot buttons. To contact the team, please send email to team@se-radio.net, or if it is specific to an episode, please use the comments facility on the website so other people can react to your comments. This episode of SE Radio, as well as all other episodes, are licensed under a Creative Commons 2.5 license. Please see the website for details. Thanks to Charlie Crow and the Podsafe Music Network for the music used in this show. The song is called Vegas Hard Rock Shuffle.